Hi everyone, my name is Matteo and welcome to my course named Python Data Essentials Programming Fundamentals. In this course you will learn all about programming fundamentals in Python, but what does that mean exactly? Well, if you want to start doing any sort of data analysis in Python, you will first have to be familiar with the basics of Python programming. I will first talk about conditional statements and how they allow us to control the flow of the program based on the certain condition. You can also control the program's flow with loops, which enable you to iterate over iterable structures like lists or dictionaries. After that, we are going to learn how to reuse parts of the code by defining and using functions. Here I'll talk about functions with arguments, variadic functions, return values, and the mutability of functions parameters. Finally, we'll briefly talk about object-oriented programming in Python. I will show you how to use classes to structure your programs around objects. Some of the major topics that we'll cover include conditional statements, comparison and logical operators, using loops, defining functions, and instantiating objects. By the end of the course, you will have a solid foundation to start using Python in your data-related projects or any other projects that require the knowledge of programming in Python. Before beginning the course, you should already be familiar with the fundamentals of the Python language. You should know how to run Python scripts from files and notebooks and how to use Python's built-in data types. I hope you'll join me on this journey to learn how to program in Python with the Python Data Essentials Programming Fundamentals course at Pluralsight. Hi everyone, my name is Matteo and welcome to the course named Python Data Essentials Programming Fundamentals. In this course, I will cover the basics of programming in Python, which will give you a great foundation to start using Python for your data-oriented projects. So let's first look at the prerequisites. Before watching this course, you should be able to set up Python on your operating system of choice. Once you do that, you should know how to run Python scripts from files. In this course, I will also use Jupyter Notebook to demonstrate some concepts, because if you plan to work on data analysis, you will definitely need to be ready to use interactive notebook environment. You should also be familiar with basic data types and structures in Python like numbers, strings, lists, dictionaries, and tuples. To get familiar with these prerequisites, you can watch other courses on Pluralsight. So, who should actually be taking this course? If you want to learn the basics of programming in Python, like control flow statements and functions, this course is right for you. Maybe you want to get started with data analysis, but you don't want to be an expert in the Python language itself. You just need the minimum amount of knowledge to start using data analysis libraries like pandas or NumPy. This is who this course is aimed at, complete beginners that need basic knowledge of Python programming. You can download all of the slides from this course together with the script files and notebooks. You can find them under the Exercise Files tab on the courses page. If you have any questions, please don't hesitate to ask them in the discussion tab, which you can also find on the courses page. And please don't ask the questions in the feedback form, because I cannot answer you there. Python supports a lot of basic data types. You can store numbers like integers and floats, strings for text, and you can group multiple values in lists and dictionaries. As I mentioned in the prerequisite section, you should be familiar with all of these types of values. This module will focus on conditional statements, and the most important data type in the context of these statements is the Boolean data type. Boolean values can only hold one of these two values, true or false. These values represent logical states which allow us to make decisions in the code. But what do I mean by decisions in the code? Well, as you know, Python will, like many other programming languages, read and evaluate each statement in the script, from top to bottom. So in this simple script, Python will first evaluate the first statement, which assigns number 30 to the variable named num1. Then it goes to the next line, which assigns 20 to another variable. After that, the sum of the values from these two variables is stored inside of the new variable num3. And then I used the print statement to output the value from the variable to the terminal. After that, I assigned a new value to the same variable and used the print statement again. As you can see, in this course I will use VS Code Editor to edit Python files. I can then run this file from the integrated terminal. You can use any IDE you like, but this is how I'm going to work with files in this course. As expected, the output of the program is 50 followed by the number 20, because this print statement was evaluated before this one. The same flow of the program can be observed in Jupyter notebooks. Since this is the Python Data Essentials course, I'm assuming that most of you are taking it because you want to start working with managing data. If that's the case, you will definitely need to be familiar with using notebooks like this one. I'm here using the same script, but I placed each statement into a separate cell. If I run the cells one by one, or all of them at the same time, the order of evaluation will be the same as the one we saw in the file. However, when you're working with notebooks, you have to watch out for these numbers next to the cells. These numbers kind of work like line numbers in a regular Python file. They tell you the order of evaluation. In notebooks, you can run any one of the cells on its own without following the order. For example, I can now run this cell with the print statement and the value inside of the num3 variable will be 20. This is because the assignment from this cell was the last evaluated cell which assigned some value to the variable. If I rerun the cell above, the num3 value will again be 50. That means that I can evaluate the last cell and the value of num3 will still remain 50, even though this assignment seems to happen right before the print statement. This is why you have to pay attention to these numbers, because they show the order of evaluation. So watch out for this when working with notebooks. Notebooks are more interactive and we can change the order of statements based on the order in which we want to run the cells. However, what if we want to conditionally control the flow of the program? In other words, what if regardless of the order of evaluation, I want to run some of the statements only if a certain condition is met? We can do that by using the if statement. You can utilize this type of statement by using the if keyword followed by some expression. In this example, the expression is simply the Boolean variable which holds the value true. So this is the same as if I wrote if true. The required semicolon after the expression marks the start of the code block which belongs to this particular if statement. The code block can contain as many statements as you need, but it has to be indented by 4 spaces. So in this case, only these two print statements belong to the code block of this conditional statement. Even though you can theoretically use 2 spaces for indentation, the Python style guide recommends the usage of 4 spaces instead. Either way, it's important to be consistent. You cannot combine the number of spaces in the same code block. So what does this conditional statement do exactly? Well, this code block with 2 print statements will only be evaluated if the expression here is true. But I can also change the value of this Boolean variable to false. In that case, the expression inside of the if statement will be false. And if the expression is false, that means that the code block that belongs to this condition will be skipped. This is why the if statement is one of the Python's control flow statements, because these kind of statements control the flow of the program. The program is no longer just evaluated from top to bottom. The evaluation of this specific code block depends on if the expression here is true or not. But this statement doesn't make much sense if I just hardcode Boolean values, because if I know what the value should be before I run the program, then I could easily decide if I want to include these print statements in the code or not. I don't need a conditional statement for this. But this was just a simple example to show you how the if statement works. I will show you why they are actually useful in the next few lessons. If you're familiar with basic data types in Python, you probably know about type conversion. In case you don't, here's how it works. The string num variable holds the string value that looks like a number, but we can see that this is indeed a string value because of the quotes around it. The print statement will remove the quotes, but that doesn't matter because if we actually want to do some mathematical operations on this value, we couldn't do it because this value is a string. To convert this string into a floating point number, we can simply put it inside of parentheses next to the keyword float. I could also convert this new float number into an integer by placing the variable next to the int keyword. As you can see, this conversion will only keep the integer part of the number. And finally, if I want, I can again turn this integer into a string with the str keyword. These explicit type conversions are useful because sometimes your program will require the value to be of a certain type. Like I mentioned, if you want to do any calculations on this number, you have to convert it from string into an actual numerical value. And values can also be explicitly converted into a Boolean value. This might seem strange at first, but once you know the rules, these Boolean conversions actually make sense. You need to use the bool keyword to convert a value into a Boolean. The none value will be converted to false. All of the numbers equal to 0 will also be false in Boolean. When I say all numbers, I mean the floating point 0 and integer 0 will both be converted to false. However, any other number which is not 0 will be converted to true. So all of the numbers are true except for 0. All of the empty collections will also be converted to false. So an empty list, empty dictionary, or an empty tuple will all be considered false. If any one of these collections has at least one value, that collection will be true in Boolean. The values that will be converted to true are also known as truthy values, and values that will be converted to false are known as falsy. This is just a terminology that you can use when discussing the code. So to sum up, none, numbers equal to 0, and empty collections are all false and everything else is true. Let's test this in the code. I created two variables, one has an integer and the other one has a list with 3 elements. Instead of just hardcoding true or false as an if expression, I decided to explicitly convert these variables into a Boolean value. If I run all of these cells, you can see that all of the print statements got evaluated. This is because any number converted to a Boolean will be true. And also, since this list is not empty, it will also be converted to true. So since these expressions are true, the code block that belongs to the condition will be evaluated. However, when you place a value inside of an expression of the if statement, the value will automatically be converted to a Boolean. So we don't actually need to do that explicitly here, just pass the value itself. To prove this, I will run the cells again and the result will be the same. Now let me change the number to 0 and make this list empty. If I run the cells now, you can see that the output from the print statements was omitted because conditions were not true. But these two variables still have hard-coded values. The if statements are most useful when the expressions are dynamic and depend on something that happens while the program is running. For example, here's a simple script I wrote in a file. The input function prints this message to the terminal and waits for the user to input something. The user's input will always be stored as a string, so I need to explicitly convert this string into a floating point number. The account balance will be stored as a number inside of this balance variable. If this balance is not 0, the expression will be converted to true and these print statements will run. I can run this script to show you. The program is waiting for me to input something, so I'll input some non-zero amount. And as you can see, the print statements were evaluated. However, if the balance is 0, then we don't want to say congratulations, you have some money, because the user has no money. So the evaluation of this code block depends on the user's input while the program is running. We don't know what the user's input will be, so this is the perfect place to use the conditional statement. And if you think about it, the conversion from 0 to false makes sense because 0 usually represents nothing, and other numbers represent that we at least have something. Same goes for the collections. If the list is empty, then we have nothing to work with. But this is just one way of using if statements. Join me in the next lesson to learn more. Truthy and falsy values are just one way to use conditional statements. We can also use comparison operators to compare two values. Comparison operator returns a Boolean value based on the two values it compares. The less than operator checks if the value on the left is less than the value on the right. If it is, the operator will return true, like in this case, because 3 is less than 5. If this wasn't the case, the operator would return false. The opposite of that is the greater than operator, which returns true if the value on the left is greater than the value on the right. Since that's not the case here, the operator will return false. You can also append the equal character next to these operators to get the less than or equal to or greater than or equal to operators. This operator will check if the value on the left is either less than or equal to the value on the right. These operators do the same thing as the operators above, but they also return true if the values are equal. Finally, we also have the equal and not equal operators. As you can expect, the operators return true if the values are equal or not equal, respectively. Since 3 is not equal to 5, this operator will return true. Now let me run this example from the slide inside of a notebook. You can see that it works as expected. These two lines were not printed because the expressions were false. To prove that these operators actually return booleans, I can simply run the expression itself in a separate cell. Since 3 is less than 5, this will return true. If I change this variable n2 to n3, the condition will return false. Now let's see the example with the user's input again. First, I'm checking if the balance from the input is a negative number. So if the number is less than 0, that means that the user is in debt. Down here we have if statements inside of an if statement. These are also known as nested if statements. There's nothing special about these statements. You can define if statements inside of another if code block, just like any other code. But these statements will be evaluated only if this outer if statement has a true expression. Of course, the nested if statements will need another level of indentation so that Python knows which code belongs to which condition. So if the balance is 0 or more, that means that the user is not in debt and the code block here will be evaluated. Inside of this code block, I'm also checking if the balance is less than 2000. If it is, the user cannot ask for a loan. However, if the balance is greater than or equal to 2000, then the loan can be achieved. Let's run this program. I will first input a negative number. This will only run the first print statement. If I input 1000, the program will say that I'm not in debt, but I still cannot ask for a loan. Finally, if my balance is more than 2000, I can also ask for a loan. Now we're getting somewhere. This is starting to look like a prototype of a program that someone might actually want to use. The conditional statements provide us with different paths that the program could take based on the input at runtime. Another type of statement can be used in addition to the if statement. The else statement always has to be defined after the code block of the if statement. It cannot stand on its own. This statement defines a code block that will be evaluated if the expression from the if statement is false. So if the expression is true, like in this case, the first print statement will be evaluated. The else statement and its code block will be skipped and the program will continue to this last print statement. As you can see, only this print statement belongs to the else block because only this statement has indentation. This one doesn't. Now let's say that I update this variable to 2. In this case, the if expression will evaluate to false, which means that this print statement will not be reached. However, that means that the else code block will be evaluated, so we will get an output from this code block. You can see how this workflow can be useful because we often also want to do something when the condition in question is false. And here's another example. I slightly modified the script from the previous lesson to include the else statement. In the previous lesson, I first checked if the balance is negative, and if it's not, I checked if it's 0 or positive. But if balance is not negative, that means that it can only be 0 or positive. So instead of defining a separate if statement, I can just put the else statement here. If the balance is not negative, then this else statement will be evaluated. And this is not only a matter of preference, this code is a lot more understandable as well. The same logic applies to the nested if statements. If the balance is not less than 2000, then it has to be equal or greater than 2000, so I can accompany this if statement with an else statement. This program is doing exactly the same work as the previous one, but this one is more readable and it has less explicit conditions. And when talking about conditional statements, you can also use the so-called elif statement. Elif is short for else if. This type of statement also has to be defined after an if statement. It cannot stand on its own. Elif allows you to define another condition. The program will first check if the number is equal to 4. If it's not, it will first check if there are any elif statements before it checks for the else statement. Since the number is equal to 3, this code block will be evaluated. You can have as many elif statements as you want. You don't have to restrict yourself to only one. But it all depends on what you need to achieve in your program. For example, here I use the elif statement to refactor the code from the account balance program. Again, this code does the same thing as the one without the elif statement, but you can see that this code is much shorter. And arguably, this code is more understandable too. If you are in debt, the first print will be evaluated and everything else will be skipped. However, if you are not in debt but have less than $2,000, then this code block will be evaluated and the else will be skipped. In case when both of these expressions are false, the else block will be the one which will provide an output. I will assume that this is the first time you see an elif statement, so you might be wondering, why don't we just use two if statements? But Think about it. What would happen if I use the if statement here? Let's run this and I will input -20. The program tells me that I'm both in debt and not in debt. This is because both if statements will run, and -20 is less than 0, but it's also less than 2000. However, when we use elif, that condition will be skipped if the first condition is true. So only one of these code blocks will be evaluated. I hope this clears up the difference. Another type of operators that you can use to form expressions are logical operators. Logical operators allow us to combine more expressions into a single expression. Let me show you what I mean. Here we have two logical operators, the AND operator and the OR operator. The AND operator checks if expressions on both sides are true. So on the left, there is a greater than operator which evaluates to true because 30 is greater than 20. The right comparison operator also returns true. So if this expression is true and this expression is true, then this whole expression is true. So AND operator will only return true if both expressions are true. If either one of these expressions is false, or if both of them are false, then this whole expression will be false. The OR operator will check if either one of the expressions is true. If even one of them is true, the whole expression will be evaluated to true. That means that if one of them is false, the OR operator will still return true. You can imagine a real-life scenario to get familiar with these two operators. For example, let's say that you want to go to a party, but only if two conditions are met. First, you have to be in the mood, and also your friend has to be there. Since I use the word "and" in this sentence, that means that both of these conditions have to be true. So you will only go if you are in the mood and also if your friend is there. However, if you say that you will go if you are in the mood or if your friend is there, that means that either one of these conditions can be true for you to go. And finally, we have the third logical operator, the NOT operator. This one doesn't work with two expressions, it only works with one. Actually, all that this operator does is negating the Boolean value. So in this case, I'm using the equal operator to check if 30 is equal to 30. And since 30 is equal to 30, this expression will return true. However, when I put the NOT operator before this value, the final value will be opposite of true, so false. This expression will return false, but the NOT operator will negate it to true. So not false is true, and not true is false. So not num here will return false because num is not 0, which means it's true, but the opposite of true is false. And that's enough of theory. Let's see these operators in a real example. I refactored the account balance script again to show you how these operators work. As you can see, I also asked the user for two more inputs, age and if the user has a job. Here you can see how the equal operator can be used with strings. I am checking if the user's answer to the job question is either Y or the word yes. The OR operator here means that if any one of these conditions is true, the haveJob boolean value will be set to true. If the user provided any other string, the haveJob will be false. Then I'm checking if the user's age is between 18 and 30. The AND operator is great for checking these kind of number intervals because the expression will only be true if both of these conditions are true. The age has to be greater than 18, but it also has to be less than 30. If the user's age is in that range, I'll just inform them that they can have some special benefits. Finally, this last part of the program should be familiar, but I also added these additional conditions for a loan. If either one of these conditions is true, that means that you cannot ask for a loan. So just like before, if your balance is less than 2000, you cannot get a loan. But now I'm also checking if your age is greater than 60 or less than 18. Finally, I'm also using the not operator with the havejob boolean value. You can see how this operator actually makes it clearer what I'm asking here. If not have job means that user cannot ask for a loan if it doesn't have a job. So let's say that the user didn't write yes as a response here. That means that the have job value will be false. Not false will return true, and if this condition is true and user doesn't have a job, then this code block will be evaluated. As you can see, you can chain more logical operators next to each other. Since all of these operators are OR, that means that if only one of these expressions is true, this if statement will run. Python will check the expression from left to right. If it finds that one of them is true, it will not go further, because only one of them needs to be true. I will not go any deeper into operator precedence, but basically if you combine both AND and OR operators in a single expression, the AND operator will be evaluated first. And just like in basic math, if you put some part of the expression inside of parentheses, that inner part will have priority. So that's all I wanted to cover about conditional statements in this module. In the next module, we will talk about loops, which allow us to control the flow of the program in another but similar way. Thanks for watching, and if you have any questions, ask them in the discussion.